Okay, in this video, I'm going to talk about the old math and then the change to new math and then to the newest one, which is called the Common Core. So for the old math, what were they teaching was a way for you to do your addition and subtraction. So the old way, which involves borrowing method and carrying over. Uh, as I said, when you're working with the old math, let's say the 34 this time, uh, taking 18 away, so you don't have enough, okay, so you need to borrow from the tens place, so you have two tens left, and then 14. 14 minus 8 is going to be 6, and then the two tens and minus 110, 16, okay? This is the way for the old math. And then for the carrying over, 34 plus 18. So this is 12, and then you write the 10 here, and then the 2. So a 10, a 310, and a 10, so which is 50. So this is the way for you to do in the old way. They taught this way. And then for the upgraded version, the new math actually is basically the same as the old math, but then without crossing anything. Okay, so for example, 34 minus 18, same question, and then they are telling you to use your mind to think about the borrowing and carrying over. So this is 14, and then you minus the 8, which is a 6. And then you need to know that you have borrowed a 10 from that tens place, and then so this now becomes a 2, a 20, and then minus 10, which is a 60. So this is the new math. Same as the 34 plus 18. Okay, so 4 plus 8, 12 without writing, and then 40 and then 50. So this is like a skipped version of the old math, but then I'm gonna explain why it happens later on, and then right now, people are talking about the Common Core. So how does the Common Core work, and then what's happening with it? Okay, so for example, again it's going to be 34, but then for the Common Core, they're telling you need to do it in the horizontal form, which I call it the row form. This is called the column form or vertical form. So for Common Core, you need to do it in the row form, which is 34 and then minus 18. So what I observed in others' video was they're telling you to count up with this number. So for example, 18 needs 2 more to become a 20, and then 20 plus 4, I guess, because I'm not really using this way to do my math. Because I use a different system. Okay, in my mindset, I use a different system. So it's 24, and then 24 plus 10 will be 34. So they're adding up all these numbers, okay? So it's plus 2 plus 4 and then plus 10, which is a 16. So this is the answer. So this becomes a plus 16. Okay, so this is called the counting up method. For me, okay, I didn't really I wasn't brought into the Common Core system because I was teaching in Hong Kong, and then in Hong Kong they're actually teaching this method, the old math. Old math. They're using the old math in general. But then in my video, in my subtraction video, I already pointed out the old math has problems, okay, which doesn't fit the our real life in the logical way. But then for this way, I understand like what happens, okay? I know why they're using this number to count up, but then their explanation is pretty poorly presented. If you're just telling the student to count up, then it's not gonna work. There's a knowledge behind this method, and it's not really meant by counting up. You don't just say, oh, let's count up with this number. Okay, 34 minus 18. We use this number to count up. It doesn't show any logic behind. You're not really teaching the student, and for teaching a method, teaching a way, or teaching a skill, you need to really explain in detail and the logic behind. If not, the students will only follow your steps of doing it. Okay, so and then their way of doing this math, okay, takes so many steps, which first of all I don't like it. Secondly, they're not well presented. Like in what kind of situation does counting up, the Common Core counting up works? Like why does it work? And then what are you doing with it? Why am I counting upwards will be a way when I'm working on my subtraction. Okay, so do you know if you want your students to learn math, you need to tell them the logic behind. You don't just tell them, oh, to count up. Then can I count down? Basically, can I count down like this? 34 minus 18. Yeah. Can I count down with this way? This is this number. So 34. This I just made it up. Okay. Although I know it can be done. It can be done. Okay. So 34. Let's say minus 4. Then I get to 30. 30 going two steps will be 28. I'm just using their logic to do the math. I don't do it in this slow. Okay, this kind of speed, these many steps, I won't do it. So 28 minus 10 will be 18. So these ones, it works too. Like then why does it work, right? So there, in most of the videos I saw, it's just talking about one way, counting up. The second thing I was thinking about was counting down. Why not, right? So it's 16 also. Hey, what about this one? What about this one now? Again, if counting up and counting down also works, can I do this? Can I count 2 steps? And then can I count 34 4 steps downwards? And then can I think about either way, 20 going up to 30? Yeah. So can I do this? Does this make sense then? One going up, one going down. Can I do that? Yeah, it's still 16. If you only think about the numbers over here, 2, 4, and then 10. Yeah, so I can do that. But then why? Why can I do that? Where's the logic behind it? And then what's happening? Did they teach you these stuff? Is it detailed enough, like, for them to actually explain the way they're working, and then what's the logic behind, and how does it actually applies to our real life. So these are the main thing your student needs to know. Teaching math is not only about the numbers, and then this will actually drag down their uh, their number sense. First of all, the number sense is not going to be built. Okay, if you are only throwing away to them, you need to teach them the logic behind. First of all, you need them to have a basic knowledge in their number sense. Okay, and then number sense can actually be built. Okay, I also saw videos talking about it's natural born. It cannot be really built. Okay, so and then some of the teachers are also saying that just let them think by themselves. It's not that. Letting them think by themselves are sometimes okay if the student has a good number relationship thinking, and then the logic behind, uh, then you can let him think by himself. But then you, as a teacher, you also need to have a great number sense when you're teaching. If you don't have a great number sense, then you won't really understand like why it works, and in what kind of situation in real life the ways you were working on, okay, works. And then, to be honest, I'm using right now. I'm using their way to do it. I fully understand like why that happens, but then all of the ways that I was using right now is not the ways I use. I I actually for the Common Core way I use it, but then I use it in a different way. My approach is more efficient. It's more logical, and then and it's more efficient. The most important thing is I saw a lot of the ways they're teaching. It's not efficient. It's not efficient enough, and then they're not seeing where's the problem when they're teaching their math. Basically, it's you need to know. Well, I can give out an example. Let's say you're moving. Okay, you're moving, and then you have big furnitures and small furnitures. Okay, and now you're in the house. So what kind of furnitures are you moving first? Is it going to be the big furnitures, or is it going to be the small furnitures? From what I observed, okay, this is an example. From what I observed, okay, when the school is teaching, or in a lot of schools, what are they doing is they're telling you to move the small furnitures first, and then it's very inefficient that way, because we all know that we need to move the bigger furnitures into the house first, and then you move the small ones, because the big furnitures are the more important part for your home, basically, and it's gonna be faster if you do that. So I'm giving out an example of what they're really doing, how they're teaching in that way. Um, they're telling you to move your furnitures, the small furnitures first, not the big ones. I move the big furnitures first, and then I move the small ones. I hope this example will be one of the it's a great reason, but then I'm not too sure how many people will understand what I'm saying. So if please observe this one. So when I'm doing my math, okay, it's just like 91 minus 18, then it's 70 something, 71, 3, done. It's like that. So it's not, I can double check it. Okay, 73 plus, okay, plus at 18 plus 73, 91, 93 minus 73 will be 18. So I'm blocked. Basically, I have 4 to 5 or 6 to 7 ways. I mainly use like 3 or 4 ways when I'm working on my math. This is what I'm doing. I'm actually, when I'm writing my question down, and then writing this one minus 18, and then my brain automatically, using my number sense also, I will know like what kind of answer is going to be for my answer. It's a sense. This is because I actually like mastered the plus and minus in my system. No one taught me these ways. But then when I was little, I was thinking about the numbers. My teachers was teaching the boring method, but then during those lessons, I was like, hey, I have another better way. And then the good thing is my teachers didn't tell me, didn't ask me to use their way, the old math. They didn't tell me. So basically, I was thinking about by myself, like why these ways work, and then what's the logic behind. I taught myself these kind of stuff, and now I'm teaching my students also. Basically, most of them can do it in my way, and then I explain the logic behind first, and then I'll tell them to practice. They need to practice and to have the change. I teach them 4 to 5 ways. They're all the same. Their speed is close to mine. It's close to mine. And then yes, so is any question is fine. Maybe 88 plus maybe 75. I don't know. 163. Multiplication maybe. 48 times 7 maybe. 200. So my first number will be 280, and then 56. So it's 336. So this is what I do. This is how I think in my mind. Maybe the last one. 700. No, maybe 712 divided by 6. So automatically 100. 100, and then it's 8. Remainder should be 4. So I'm not quite sure about if this is right. So I'm gonna recalculate. It should be right. Yep. So what I'm doing with my checking is using the multiplication. So 6 times 118. So 660. This is what it goes into my mind first. 660, and then 48. So 708. 708 adding the remainder 6 will be 712. So basically the whole system, I'm moving the big furnitures first, okay, and then my small ones. If you can see, I can't teach you right now, okay, because it's gotta take me maybe a few videos before I need to have maybe 4 to 5 videos at least talking about the plus, talking about number sense, and then afterwards I may talk about like how to do my additions, subtractions, multiplications, divisions. Even fractions is fine. Fractions, percentage, they're all the same to me. And this is around the speed. Basically, this is around the speed people should have. And if you're learning in the old traditional way, basically you can't. Because you may have the concepts, but then the skill part has major problems. Even with the upgraded version, which is the Common Core, there are many problems inside. How do you learn math? Remember, how do you learn math is that you need to understand the logic behind why it happens, why counting up, why counting with this number, why counting with 18. Can I do it in another way? Why is it counting upwards a way to find 73 for this question? Why? So if you don't know, if you don't understand the reason why, do not do not follow. Do not follow that way. Think about it. Think about math in the logical way. Try to think about the real life situations. Um, 91 minus 18. So think about something related with the real world. I'm paying as usual. I always use the paying. I have $91. I'm buying something uh, 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 that costs me $18. So how am I gonna pay? How am I gonna pay for my $18? Maybe fruits, maybe food. How am I gonna pay? So this is what you should be thinking. And if you're a parent, you think about these kind of stuff first. Think about a question related with subtraction, related with additions. Okay, what is addition? What is subtraction? Okay, you need to think about these when you're teaching your kid. Do not just focus on telling a skill to them. Do not focus on these because it's super important for them to have an idea of what's happening first before they learn. If not, they're only listening to you. Some of the students in maybe a more serious cases, they will think about minuses addition afterwards. So there are side effects. I always mention about side effects. There will be side effects if you only teach them a skill. So do not tell them to just follow your way and then like, oh, I can count up. Why can you count up? What's the reason behind you can count up? As I just said, 91 going down 73 is 18. I can do count down also. Why is that? Why does that work? So remember, do not follow what you don't understand. Okay, especially the school. Is the school is not really observing the problems with old math. So why are they changing? Also, why are they changing from old math to new math and then to Common Core? They are seeing problems coming out. They're seeing people that can do math doesn't require them to write a lot of stuff. Okay, they don't need to borrow and stuff, and then they're seeing problems, but then they can't really solve it yet. They don't know what's going on basically. So and the steps they're performing. Okay, the teachers are performing the skills. There were like 4 or 5 steps when I was doing my 34 minus 18. um, it doesn't really work that way. They're moving, they are moving small furnitures first, and then they're moving the big ones. So it's very inefficient that way. All right.